We are solving a question from the topic of capacitors that has appeared in 21st January, shift 1 of JEE Mains 2026. You can pause and read the question. In summary, they have a parallel plate capacitor whose capacitance is C, but now one third the separation between the plates is filled with a dielectric of dielectric constant K, and they are asking what is the new capacitance of the system. So this is happening. You had initially a capacitor whose capacitance was epsilon naught A by D. Now they have filled one third the separation between the plates. Initially this was D. Now this is D by 3. They have filled it with a dielectric of relative permeability or dielectric constant K, and they're asking what is the capacitance of this system. So there are two ways of doing this question. So method number one would be to use the formula. Whenever you have this type of a system in which the separation between the plates is filled with various dielectrics of thickness D1, D2, so on, you can apply the formula. The effective capacitance will be epsilon naught A divided by sigma D divided by K, Di divided by Ki, where Di is the thickness of the ith dielectric and Ki is the dielectric constant. So here we can say, if we apply the same formula here, up to distance D by 3 we have a dielectric constant K, and for the remaining 2D by 3 we have a dielectric constant of 1. So epsilon naught A divided by, if we take the LCM below, we can take D by K common. We will be having just 1 plus 2K divided by 3. So now here epsilon naught A by D can be replaced by the initial capacitance C. So this will become 3kC divided by 2k plus 1. So which clearly is option 4. But we can do it by another method. We can break this as a system of two capacitance in series. One capacitor having the distance between the plates D by 3. So his capacitance C1 will become K epsilon naught A over D by 3. It is in series with another capacitance whose distance between the plates is 2D by 3. His capacitance C2 will become K, no K here because there is no dielectric. So epsilon naught A divided by 2D by 3. If you will see carefully, the value of C1 is 3kC and the value of C2 is actually 3C divided by 2. So now these two are in series, so C effective will be equal to C1 C2 divided by C1 plus C2, which is equal to 3kC into 3C by 2 over, you have 3kC plus 3C by 2. You can take 3C common everywhere and you can cancel out the unnecessary terms. One of the 3C's will surely get cancelled from numerator and denominator, and this will lead you again to 3kC divided by 2k plus 1. Please do not forget to take LCM in the denominator. You will get the same answer.